this is Professor Nelson with the Jewelry Design Department of the Fashion Institute of Technology, doing another tutorial in my series of tutorials for rhino modeling. This is for JD237. Doing what we call, what I'm calling the Maurice ring, based on this image right here. Okay. Talk a little bit about strategy. This is your drawings at this point should pretty much mirror what I have here. Be a copy of it. When you start modeling a project, it's good to start thinking in terms of what is your overall strategy going to be, and one of those elements of strategy can be is whether or not the piece is primarily going to use sophisticated modeling, or surfacing I should say, sophisticated surfacing, or sophisticated transforms. Sometimes you need to use both, but usually one will predominate. You're either going to do really tricky surfacing and then tweak it a little bit using transforms, or you're going to do very simple surfacing and really do serious manipulation with the transforms. I'm going to model this ring. We are going to model this ring using that approach. We are going to use fairly simple surfacing techniques, but some fairly exotic transforms. The next thing that comes to mind when you're doing a modeling project like this is what to do in what order. Okay, and that's usually based on the importance of the motif or the element, also what other motifs you have to have in place before you can make it. For example, the last thing we'll model on this ring will be these collets, because these collets have to grapple both the central motif and the side shank, and the shank on the side. And until that you have these two elements, you can't really intelligently craft or model these clamps or collets. So we're going to model these two elements first. And between these two, the shank is the hardest, I would think, to surface. And also, the center motif needs to interact nicely with that shank. So I'm going to begin modeling with the shank. I'm going to begin by modeling just the center flute of this shank. And this is going to be just a rib, so I'm confident and comfortable working with it that way. So I'm going to use my arc tool, the arc start and direction tool right here, and turn off my grid snap. And I want to build it coming off of the ends of these two curves in my drawing. Anything that I have that'll give me this width. The problem is, if I draw it right now, I'll be drawing it on the top C-plane, which I don't want. I want this to stand up vertically. So I'm going to go into my right C-plane before I click. Beginning of arc, end of arc, and direction. And I can pull this up until I get an elevation on that arc that I like. And I think that's pretty good right there. Okay. And I'm going to move it so that it ends up with the top of it right here at this intersection. And that's because I want these flutes to fade out. I want them to go from smooth to rounded. I basically want the fluting to end somewhere in this area. So I'm going to move from the quadrant, because every arc has a quadrant, because every arc is a portion of a circle, down to the intersection, like so. I want to draw a straight curve, line using the line tool and the end snap that equals that same distance. its midpoint to the intersection here. So now I have these two curves. I'm going to copy this forward. I'm going to bring back my curves so I can see them. Holding down the Shift key. Oh, I only want to copy one of these. I'm going to move this to where I think I want that shade to fade. That groove, that flute to fade. And that's here. And I'm going to do a simple loft. Between two curves. Okay. And I'm going to do another simple loft. From the edge of the surface to here. I want it to match the start tangency right here. And hit OK. And with this, if I copy this, you can see that I've pretty quickly created the basic geometry that I need. Okay. I might want more control over this later than I have, so I am going to back up. And use history. I'm going to record history for this first loft. That'll now make it possible that if I want to move this curve back and forth, the surface will update with me. And I'm going to record history again, loft again, surface edge to here, match start tangent, and hit OK. And then once I've done that, I should be able to grab this curve, in theory, and move it either way, and this will update. Record history, and copy. And record history, and copy again. So now, in theory, EMAP, if I grab that curve and move it forward, all the surfaces will update. If I pull it back, all the surfaces will update. That'll come in, could come in very handy later on. Okay, so that's the surfacing for the shank. I told you that the shank is going to primarily be a very simple surfacing problem with some sophisticated transforms. And the sophisticated transform we're going to use is going to be a flow. So I need a surface to flow this from and to. both sides. It's from the same position where that first arc is at. And I'm going to copy it. From this intersection back to this one. That layer's locked. I'm going to take my center line and I'm going to offset it through point, both sides, to the width of my shank. Going to clean it up with fillets. Set to 0. That quick trimming and cleaning up tool. And this is the makings of my start surface for my flow. Now I want to make my destination surface. I'm going to create a flow that both moves and tapers this shank at the same time. I'm going to grab the outlines of my shank and I'm going to flow them along curve. Base curve, I'll use the end of my original curve, end curve, or target curve, this. And that will give me a three-dimensional version of those curves. Before I go any further, I want to make sure that my numbers are good, my math. If I drew this correctly, this curve, which is 67.387, should be the same length as this curve. It is. Just always good to double check. I haven't worked on this for a while and things could have happened. Okay? So that's fine. That's good. I'll go ahead and draw a line tool. Now this is going to be for reference. I'm actually not going to use these curves, but they will be a useful reference for me as to what that shank is going to look like, hopefully, when I'm done. Okay? I want to take a look at that. I'm going to look at it from the right view. See how it has this kind of soft, organic thing going on? I don't really want that. I'm more confident with a straight line. I'm going to project to the right C-plane when I draw. So start of line, project is turned on. I'm going to grab the top of the shank. I'm going to go ahead and go both sides. And I'm going to go to the bottom of the shank. That way, since I projected, it'll keep that line flat. Which I like. That's good. I'm going to extrude this surface. Remember, extrusions go normal to the current C-plane. So I can't extrude right now, or it's going to want to extrude this way. So I'm going to change to my front C-plane and extrude front and back. I'm going to go back to my right C-plane and extrude this front and back. I'm going to mirror this over. I'm going to use these two curves to trim off this surface to get myself a nice three-dimensional representation of what I think that surface is going to look like. I'm going to check that against my drawing of Maurice's ring. See, when I see Maurice's ring, this is a much more rapid taper than what I feel here, but what he has underneath here is that. So I'm going to stick with it. I'm not really confident with it, but I am going to stay with it for now. I'm going to use this curve. Actually, I'll explode it. And see if I can't trim this off. Top C-plane, mirror it over, grab both of these, and trim. Yeah, that works. And I want to trim this surface down the middle, so I don't have to. It's already a poly surface that was already, because the seam of this curve is at the bottom. When I trimmed it out, it left this as two separate surfaces. Okay, I can throw away those reference curves now. I don't want them anymore. Now they'll just confuse me. This is my basic shape. This is what I want as my basis to start from. It's still not enough information for what I need to do, though, because this is going to be my target surface. And I do not want my target surface to be the exact size of my finished shank. I need there to be surplus material for it to work properly. So, going to do some offsetting. Going to offset this curve. Something like that. How much was that? That's 0.94. I'm going to make it consistent, so 1 millimeter. I'm going to offset this curve 1 millimeter. Going to offset this curve 1 millimeter. The only curve I won't offset is at the base. Because that needs to come flush at the bottom of the ring. Okay, I need to make these curves fit together. And the way to do that is going to be a fillet curve. So notice how it extended the curve out when it made them meet. And one along the bottom. So once again, repeating myself. In this modeling strategy, the surfacing is simple. I'm going through a considerable amount of work to set up a proper flow. I'm going to now flow this along curve. Base curve, target curve. So now I have this. And this is actually what I am going to want to have for my surface, with the exception that I do want a nice straight taper down the side. So once again, I'm going to come, I shouldn't have deleted that so quickly, I'll hide it instead. I may want that later. I'm going to come into my right C-plane, right view, look at that. See, it has that strange organic sort of thing going. I don't want that. So I'll come back to here, right C-plane, line tool, project, and see how it projects it onto the C-plane? Both sides. And that should look very uniform, as a nice, fairly uniform offset. But doing it this way, I know it's correct, and that's important to me. I'm going to extrude this back out again. And I'll extrude this from the right C-plane. Again, don't want that to move. Mirror it. Trim. Okay, this helps me to explain what happened before. See that seam on this surface? When I use this upper curve to trim it, I'm going to mirror it over first. When I use this top curve to trim it, it'll leave me two surfaces, because this center section will be gone and there's a seam, and that seam will fall apart and I'll have two surfaces. I want to explode these. I only want to keep the top curve, so hit my control button. And I click to deselect those from the selection. Delete to throw away the curves I don't want. Pre-select these curves to trim. Trim. And then delete those curves. Throw one of these away. I only need one. That is a flow surface that is almost complete. It's almost ready for me to use. The problem is that it's a trimmed surface. If I turn on the control points, I have something like that, which is completely useless. So, rather than try and rebuild the surface or rework the surface, I'm just going to make a new surface. And the way I'm going to do that is I'm going to duplicate the border, throw the surface away. Explode this. It should come into 4 segments. This is important because I don't want poly curves, because if I have a poly curve, I'll have a poly surface. I want a smooth surface, so it's important to me that each one of these curves is one single curve. 1, 2, 3, 4. If I'd have seen 6 segments or 8 segments, I would have known that somehow Rhino threw me a poly curve when I didn't want one. So just hygiene, making sure that what I see here is what I expect to see. And I will use this to make my surface now, doing a bi-rail sweep. Rail, rail, section, section, enter. That's good. I am going to rebuild this because I want the math to be consistent. It looks pretty consistent now, except for I also want to have some math in the middle here. Okay, whereas this doesn't. This is just outside curves because it's a first degree surface. I'm going to want to make this at least a 3rd degree, if not a 4th degree surface, because I may want to modify it later, and there's not much I can do with a surface that simple. So I'm going to rebuild. F5 is our keyboard shortcut, but you can also find that man with a hammer. Okay, I want to see what it has now. It's got 18 points. I'm okay with that. 18 seems to be holding well, so I'll keep 18. V, I want 5. I want a center line down the middle, and 3rd degree curvature is fine for me. That's my new surface, and I like that. That's going to be fine for what I want to do. This curve is no longer important to me. I'll get rid of it. Bringing back my top view drawing. Okay. I now want to draw my flat surface. And I was wise to not throw that away because I did indeed want to keep it. The full width of this surface here is how wide my base surface has to be. So I'm going to offset this curve, both sides, through point, until it grabs this corner. And I want it to be this length as well, so I'm going to keep that. I use that to trim off the extra length on these two. then the last curve is on the ends here. I'll go ahead and re-hide that. So here we have the outline of the target surface versus the outline of the base surface. I'm going to go ahead and create my base surface. I'm going to use the same surfacing tool, bi-rail sweep. I'm going to go ahead and join those curves together and hide them. So I just have the surface to work with. I'm going to bring back my target surface. It's important to me, and this original rectangle can now be removed. I don't need it. Actually, since I'm never sure, it makes sense to hide it instead. Or even better, I'll group these together and I'll put them on my storage curves layer, where I can find them later if I want. I want the math of these two surfaces to match, and the first aspect of that math that's important to me is the directionality, the U's and V's, that they line up. So that's the first thing I'm going to do. I'm going to come here and hit Extract ISO Curve. Click my surface, and I want to see which way that goes, that very first direction, which is the U direction. It's running vertically along the surface. It's going lengthwise. I want to see if it does the same thing here. It does. Okay? It may not have, and if it hadn't, I would have had to have flipped the direction of the surface. But that works. So, next thing I'm going to do is change the point count. So I'm going to rebuild it. Okay. Right now it's 4, 2, 3, 1. I want it to use the same numbers I put in before, which happen to be the same as for that surface. And now I have a flow surface and a target surface that are mathematically friendly to one another. Now we'll go ahead and take these curves, group them together, and put them on the storage layer. Okay, now it gets interesting. I'm going to flow this surface, these two surfaces, using my new surface information and see what I get. Flow along surface. I'm not even bothering with history because this is just to see what I get, to see that I get what I expect. Okay, very important that I check that. Okay, you see how far down this is, how tight that taper is. Okay, I just wanted to look at it. I'm going to grab all of these and I'm going to use history and I'm going to flow them along the surface. I'm going to turn off these layers. I'm going to put these surfaces on a different colored layer. Simply so I can turn off the layer that the flat ones are on and get a better look at what I have here. I want to see that original surface I made. Okay, I am sacrificing a little bit at the bottom. I've lost some of that hard taper. And I can decide in a minute if I think that's important. But overall, I'm happy with that. I do want to move where that fade out is. I want that fade out to start further up the shank, farther up towards the center. Now, if all my history works properly, you see with how that works, that before, after. Going to move it a little farther still. I think that's, well, something in between. That's pretty good. I like that. So, by the way, that changed this as well. You just can't see it because it's turned off. But it does affect surfaces on layers that are turned off. The history will be updated. Now, I really don't mind this taper. I'm going to mirror this over with history. But it is not quite as tight as Maurice's was. So, what I can do about that? I can take this surface and I can taper it. Remember, transforms are always C-plane dependent. And actually, I think I'm going to unhide this again so that I have it so I can see when I approach what I want. I'm going to lock that layer though because I don't want to accidentally grab that surface. So transform, taper, start of taper axis. Now the start of your taper axis is the part you don't want to change. So in my case it'll be the top of this. I want the bottom of the taper to close in, but I want to keep the top the same. So that's where I will start. But before I go any further, it's important. Okay, so start there, end there. I want flat to be yes. I want infinite to be yes. I'm going to hold my shift key. And you can see I can drag this in a little bit. And when I do that, my shank tapers with it. I think that is a better representation of Maurice's taper. I think I may have gone a little too far. So I've undone the taper. I'm going to do it again, which is good. It'll give you a chance to see it done twice. Start of taper, I want it to be the part that I don't want to change. It's good to put project on. It should project automatically. Transforms usually do project to the seaplane, but just to make sure, I always make sure it's set to do that. There are a number of geometries that'll work, but I want to make sure it's good right there. I do want it to be flat. That way it doesn't transform three-dimensionally. It doesn't taper in all directions. I want it to simply taper from the side, so I want it flat. Infinite, yes. In theory, you can taper just sections of geometry. So you could pick just an area. Infinite means it's going to kind of taper to infinity going down at the bottom. I have found that when I don't have infinite checked to yes, that I get some strange distortions at the bottom of my transform. Especially when I'm clicking right at the bottom of the geometry like I am now. It seems to make difficult math for Rhino, so I hit infinite just to make it easier. And I'll taper it a little bit less this time. Yeah, I like that. Okay, so that's done. Now, I'm just about finished with this, but I do have to now do some finish surfacing. Because of course that's not the thickness of my shank. By the way, now that I've found what I want, I can delete these. I'm actually going to hide this. I'll throw this away. In theory, I should be able to grab those surfaces, the same surfaces, and flow them. Flow along surface, and I should get the exact same. See? The fact that I changed that taper on the surface is now in the model, and anytime I flow, I'm going to get the same thing. That's important. Because now I'm going to finish surfacing the shank. And the way I'm going to do that is I'm going to make a copy of this, because I might want access to this history later. And what I'm about to do is going to destroy history. So I want to keep the original in my file, and I will do that by grouping it together, which does not break history, and putting it on the storage layer. And I made a copy to my clipboard first. So now I can just paste that back in. This doesn't have history attached because it's a copy. But that means I can join it together and do other things without breaking history. I want to extrude straight down from this. I want to make a block of material. So I'm going to, several ways I can go about doing this. The easiest is to copy a border. See that? Project that border to C-plane. I'm actually going to go into the front C-plane, my usual vertical C-plane, just so I can move it up a little bit higher, because Rhino loves an overlap. And then I can just extrude this straight down. I don't need both sides option this time, so I hit B, enter. And I want to make this plenty thick. I can throw away that curve now. use these to trim that off. And I'm going to join them together. Like so. And I'm going to flow this. Not bothering with history because I'm just doing it to look. I want to see how thick that is compared to my front view. See, it looked like it was really thick, but as you come up here, that's not a lot of spare space. Okay, I'll leave that. That's good. Problem with it is I don't want this hard corner. I really rather hate the hard corner. I have a couple of choices with this. The easiest one is going to be a fillet, if it gives me a nice result. Solid fillet edge. And I'm going to say, I'll try 1 millimeter radius. That's actually pretty nice. I could do something fancier, but there's really no call for it. Okay. And now I will flow this. See if I like what I have. Let's emap it. See if I've gotten anything really strange at the bottom. See, you'll notice that those fillets become more distorted down at the bottom of that taper, leaving me with a fairly squared off shank. That's what I wanted to see. I don't like that. So I'll undo. And repeat the fillet. And this time I want to adjust one of these. See, it says select handle. I'm going to grab the center of this and click on it. I'm going to type in 1.8. Hit enter. Do the same thing over here. It gives me a variable radius on that fillet. Going to see how that looks. Just changing layers, guys, so that I can see. I can turn off other geometry and get a clear look at it. I think I'm going to like that a lot better. I like it better. I don't like it a bunch better, but I like it better. And here's the question. Does that fillet cut into here? And it does. See that? I can't have that because that'll give me a strange... I need that fillet to all take place outside of here. Okay? So, what that tells me is that I can't use this technique. At least I can't use it all alone. I'm going to have to do something more sophisticated when the model is finished. But it is a useful starting point, so I will keep that fillet on there. make that a little bigger. Type in 1.2. And I'll adjust the one in the back to 1.5. Flow it. It should be pretty decent, and it should remain clear. Yeah, it remains clear here. So, I mean, barely clear. I'm not really in love with that. Yeah, it's too close. One more time. Fillet edge. 1.2. Set that to 1.4. Flow it. And I believe that will take care of it. Yeah, that's fine. Going to remove this surface on the inside. Solid extract surface. Going to mirror it over. Join it together. I am not going to trim this up or fill it in because there's no point at this early stage, but I will extrude a surface and look at it just to see if I like how it looks. It gives me an effect similar to trimming it off without having to commit to trimming it off. Three flutes, fading out at the bottom, picking up again, and that's fine. Okay, that's the first stage of modeling this ring. Thank you for watching.